Remember how I said that Miss Tatiana, how a way of doing it is looking at the picture and see where you're going. That works most of the time. Yeah, you remember that? How about this problem right here? This is a very famous function. It is called the Heaviside function. This right here is 1. The Heaviside function is 1 at 0, and it is 1 everywhere else. But then it is 0 and anything that's less than 0 over here. I guess I should have drawn it in blue. Hold on, let me redraw it in a different color. It's not going to show up well. So I have a graph is in blue, closed circle right here, and it goes always 1, open circle right here, and then always 0. The Heaviside function h of x is a piecewise function. It's defined as 1 when x is greater than or equal to 0, and it is 0 when x is less than 1. Looking at the picture right here, if I ask you to find the limit as x approaches 0 of the Heaviside function, anybody know what the answer is this limit's going to be?
Is it going to be 1 because it's the closed circle?
I have one person saying it's 1 because of the closed circle. Miss Kamari, that's how you pronounce it?
Yes.
Anybody else? Mr. Maurice? You have a solution for me? This is Morton. That's the last name.
I'm still trying to work through it.
Well, you can guess. There's 1 right here. There's 0 down here, and then there's lots of other numbers in the number line. You can guess. Okay. Anybody else? Anybody else?
1.
1. Anybody else? Anybody else?
I say 1, 2.
Okay. You say 1, or you saying 2, or you saying 1, 2?
I mean, I'm also saying 1.
Are you saying 12?
I'm saying 1.
Mr. Maya?
I'm saying 1, 2.
So you're saying 12. Okay. Bennett?
No, 1.
Oh, okay, my bad. Bennett, you have an answer for me? Okay. So yeah, so Mr. Bennett's just not here, huh? Okay. That has been noted. So let's go back before we get to the answer. Let's go back old school. Old school. If I wanted to find the limit as x goes to 0, what that would mean is I would have a number line, and at the center of the number line, I would have 0. I would then go to the left. The next number over would be -1. And then if I keep walking, it'll be negative 0.5, then negative 0.1, right? Right? Me approaching in this direction. If I go on the right side, I would have 1, then I have 0.5, then I would have 0.1. And I'll take all of those numbers and I'll put them in a number line. So a table of values, sorry. -1, -0.5, -0.1, right? Then I'll skip 0, then it goes 0.1, 0.5, and 1. Yes, yes. You remember this old school back in the day, earlier today? That's how we used to work these things out?
Yeah, I remember this method.
So if I take -1 and I plug it into the function -1, the answer is 0. If I take -0.5 and I plug it into the equation, the answer is 0. If I take -0.1 and I plug it into the equation, the answer is going to be 0. Have I lost anybody?
Wait, which function are you plugging it in?
I'm plugging into this function right here, the heaviside function.
So
That function says if the number I'm plugging in is less than 0, oh my goodness, that should be 0 right here. If the number I'm plugging in is negative, then the answer is 0. So I see all of these are negative numbers. So
yeah, I got you.
Similarly, if I take a positive number, if I, for example, plug in 1, then the answer is 1. If I plug in 0.5, then the answer is still 1. If I plug in 0.1, the answer is 1. So my question to you is, are these two functions squeezing towards the same number? Is there one single number in between them that they're both getting closer to and closer to and closer to?
No.
No. Whenever we have a case where we do not have a consistent value that the two sides are squeezing into, are always getting closer and closer to, we say the limit does not exist. So most of the time, when you work stuff out, it works out just fine and you get that limit and your limit is good. But every once in a while, you run into a function where things don't work out, where the numbers aren't squeezing towards the same value. And when you have that happening, the limit will not exist. Questions there? Comments?
Can you just say what makes things not exist again? Like
Limit does not exist when the limit from the right, the limit from the right, R-I-G-H, and the limit from the left do not get close to the same number. Do not get close to the same number. I guess I should have said when I should put in front of here, when the limit from the right and the limit from the left do not get close to the same number, the limit does not exist. You often write it as simply D and E. Does not exist.